The graphs of the polar curves r equals 3 and r equals 3 minus 2 sine 2 theta are shown in the figure above for 0 to pi. Let r be the shaded region that is inside the graph of r equals 3 and inside the graph of r equals 3 minus 2 sine 2 theta. Find the area of r. The area is following this curve right here, which is not the circle, which is the 3 minus 2 sine 2 theta. And that's from 0 to pi over 2. Now to find the area of a polar curve, it's 1/2 integral from a to b of r squared d theta. Here's the 1/2, the a to b, in other words, the 0 to pi over 2. Here's the r squared, because we're squaring this r right here, d theta. And then the area starts following the circle, and it's a quarter of a circle. And that quarter of a circle is 1/4 pi r squared, which is 3 squared. And there's where we get the 9 pi over 4. So we're adding 9 pi over 4. Type all this in your calculator, 9.708. The graphs of the polar curves, r equals 3, are shown in the figure. Yeah. Find the curve, for the curve, r equals 3 minus 2 sine 2 theta. Find the value of the dx d theta at theta equals pi over 6. Well, x equals r cosine theta. So x is equal to, the r is 3 minus 2 sine 2 theta. So 3 minus 2 sine 2 theta. And then times cosine of theta. And that's what it says right there. Now, we're just evaluating the derivative when theta is pi over 6. Since we can use our calculator for this one, don't take the derivative of it. That's a waste of time. The calculator will do that for you. Letter C, the distance between the two curves. Oh, no, that's the answer. The distance between the two curves change for 0 to pi over 2. So the distance between them is changing. Find the rate at which the distance between the two curves is changing with respect to theta when theta equals pi over 3. So the distance is all the way from 3 minus out this curve right here. So there's the 3 minus the other curve. And 3 minus 3 is 0, and then you get 2 sine of 2 theta. And we're evaluating that, the derivative of that, how it's changing. So this is the actual distance. This is how it changes. We're evaluating that when theta is equal to pi over 3. And we get -2. A particle is moving along the curve r equals 3 minus 2 sine 2 theta, so that d theta dt equals 3 for all time t greater than or equal to 0. Find the value of dr dt at theta equals pi over 6. Well, we know what dr d theta is, and we know what d theta dt is because it says that right there. So if we take dr d theta and multiply it times d theta dt, these are going to cancel out, and we're going to get dr dt. So let's see, what's dr d theta for this one? We can get that. We can take the derivative of this, and then we just need to multiply times 3 because it gives us this piece right here. Well, I think, did we already calculate? I don't think we did. Yeah, we did. We calculated the derivative back here at -2. And we're just going to multiply by 3, so we end up with -6. The growth rate of a population P of bears in a newly established wildlife preserve is modeled by the differential equation dP dt is this. And this is logistic, where T is measured in years. What is the carrying capacity for bears in this wildlife preserve? Well, the carrying capacity is sitting right there. It's 100. What is the bear population when the population is growing the fastest? Populations grow the fastest when they're at half the carrying capacity. What is the rate of change of the population when it is growing the fastest? Well, then we're just going to plug 50 in for P. So 0.008 times 50, 100 minus 50 is another 50. You end up with 20 bears per year. The graph of f of x equals x squared is given. The secant line from the point 0, 0 to 2, 4 is also given. Find a value for x where the slope of the secant line is equal to the slope of the tangent line on the interval 0 to 2. And really what we're talking about is the mean value theorem. So we take the derivative of the function, and we usually use the c for finding the missing value, the value we want. So we have derivative equals old-fashioned slope, y2 minus y1, x2 minus x1, 2c equals 2, c equals 1. Now, what that's saying is that the slope of the secant line and the tangent line are the same along this curve at x equals 1. Given the chart above, find the derivative of the inverse at 3. Well, we know that f of 2 is 3, and for the inverse, because of this, we know that f of 3 is 2. F inverse of 3 is 2, excuse me. So if f prime of 2 is 5, then f inverse prime at 3 is 1/5. So these are reciprocals of each other. Now, AP used to love this question. This is typically a multiple choice question, but maybe they might fit this into the free response question. And I'm referencing this in 2020 during the coronavirus pandemic. And that year, it was only free response. So if you're watching this at a later date and wondering why I said, talked about multiple choice, that's why. A spherical balloon is inflated with helium at a rate of 100 pi feet cubed per minute. How fast is the balloon's radius increasing at the instant the radius is 5 feet? So we're going to take the volume. We know that dV dt is multiplied by 3, the 3 goes away, 4 pi r squared, and then dr dt. Well, we know that the volume's changing at 100 pi, so there's 100 pi, and we know the radius is when the radius is 5. So we have 25 there. That's actually 100 pi, so when we divide, we get 1 foot per minute. How fast is the surface area increasing at that instant? Here's the surface area, so ds for surface area. dt is 8 pi r dr dt. Well, we know what dr dt is at this instant. We found that over here. It's 1, and the radius is 5. So it ends up being 40 pi feet squared per minute. This is the fundamental theorem of calculus. The derivative of the integral, they undo each other, kind of. To find this one, we plug x squared in for this t. So we get cotangent of 3x squared. But then we multiply times the derivative of this would be the inside. So we got to multiply by 2x.